Hi, Kranti.
Hi Sid, hi Raghuir. Yeah, so let's continue with the mapping part that we were discussing the last day. Um, yeah, so as discussed in the mail, so there will be a class tomorrow also on Friday. Um, so at the same time, so we'll having a couple of hours class. Okay, thanks for replying back to the mail. Right. So in the last class, we were discussing mapping. So in that mapping section, so we have seen what are the different default geographical rules that Tableau can identify automatically, and what are the different map types, symbol maps and field maps. So we have seen what are different types of these maps, and also we have looked into an example uh, to modify locations. So we've seen how we can modify locations for west, central, international, south, and east on a US map, and assign different states for the distribution center regions. Okay, so we also seen how we can use images to show the data and the size of the trucks. Okay, so we have used the size of the trucks to show different distribution centers data. Okay, so we also seen how Tableau performs automatic geocoding of data. So how we have seen that Tableau first reads first few rows of the data and also the field names and identifies the data type. So if any geographical field is identified, so the associated geographical rules are automatically assigned in Tableau. So we can see that using using the visual cues like the symbol that you are seeing on the screen, like global symbol. So that means Tableau has automatically identified the fields like city, like here. Okay, so we'll see what are the different other options in mapping. Okay, so the next topic that we are going to discuss is combination maps. Combination maps, right? So this is a topic that we're going to discuss today. um, okay, so within this combination map we have dual access maps as well. So we'll also cover the topic. So what is a combination map? So if you combine both the symbol map and the field map in a single worksheet, then it is known as a combination map. So we've seen what a symbol map and a field map is, right? So this is a field map, and uh, if you use a um, symbol, so this is a symbol map. So if you combine both this is a field map and this is a symbol map. So if you are combining both symbol map and a um, uh, symbol map and a field map, then it is a combination map or a dual map. So combination maps can be designed in the form of a single pane, which is known as a dual axis maps. Okay, so in the form of a separate panes. Okay, so if we do it in the form of separate panes, it's an individual axis map. If we do in single pane, so that is a dual axis map. Okay, so you have to note that maps are the only chart types in Tableau which do not display any axis. So rest of all the map chart types will have access to them. So this is also one of the interview and then the certification question also. So you may be asked what is the chart type in Tableau which doesn't display any access. So the answer is maps. Okay, on maps Tableau will not display any axis. Okay, right. Okay, so we'll perform a task now. So to display, um, to design a combination map to display country-wise sales in the form of a symbol map. Also, we'll display country-wise profit in the form of a field map into a single worksheet. Okay, we'll click on country geographical field and drag sales into size and label. Sales into size and sales into label. Okay, so you clicked on country and also drag sales into size and label. So and we'll drag latitude from measures. So there's latitude in measure. So we'll drag latitudes from measures and drop it into rows. And also, so it's automatically done. So if if it is not there, for example, if you see, so if you take sales like this, then you have to, then you have to generate a uh, generate a view like this. However, if you um, directly click on the uh, directly click on the uh, country name, so these latitude and longitude will automatically get generated. So we'll go back to the view that we had earlier. Right. So if we actually drop latitude into rows, so you just observe something has happened like this. So Tableau has generated multiple marks card. So if you have clicked the latitude from measures and then drop that into rows, so what will happen is Tableau will generate multiple marks cards. So there was only a single marks card before, so you are able to see latitude here and longitude here. So there are multiple marks cards which are generated. So I'm undoing it. So before that there is only one single marks card. So if you use latitude from measures into rows, so what happens is multiple marks cards are generated like this. Okay, so click on first latitude marks card and remove sales from size and label. Okay, and then drag profit into color. Drag profit into color. So so now we'll see what is a single pane combination map or a dual axis combination map. Okay, so we'll click on the country geographical field and then uh, drag latitude and drop it into rows. So click on the first latitude and then drag profit and drop it into color like this. Okay, so we'll click on the second latitude drag cells and drop it into say drop it into size. So and then drop it into size. Okay. So right click on the second latitude and select dual axis. Now you have to right click on the second latitude. You have to right click on the second latitude and click on dual axis like this. So this has created a dual axis map, combination map like this. So which is having both field map and a symbol map. So we have two types of maps. One is a field map and a the one is a symbol map. So um, we can combine both these maps into a single map like this. Okay, so we'll perform a second task in which we'll display country-wise order quantity for every department in the form of a pie chart and number of customers in the form of a field field map in a single pane. So we'll keep geographical field as a country, and we'll also in one of the fields we'll keep latitude and from measures, and then we'll keep that into rows like this. um, in the first latitude um, so in the first latitude marks card, what we'll do is we'll keep sales into color. However, what we'll do is we'll see if we can change this aggregation. Okay, so we'll keep that as a sum itself, and we'll go into the second latitude and we'll select um, pie chart. Then drag department into color. Drag department into color and order quantity into size and angle. So doing so, so we are getting a dual axis map like this, where we are showing within this point map. So we are showing different departments in the form of a pie chart. Okay, so earlier we were showing only the total values. So we are further dividing the total values into departments and showing that in the view like this. And we are also showing order quantity in them in the form of a tooltip. Okay, so this is also one of the dual axis charts that we can display in the view like this. Okay, right. Right. There is also a nested dual axis. So if you place one dual axis inside the other, it is known as a nested dual axis. So in maps, it is possible to create the nested dual axis. Okay, so So we'll design a nested dual axis map for country-wise total sales in field maps, total profits in circles, and total order quantity as circle, and number of customers as square. Okay, so we'll use a different map. So we'll click on country geographical field. From measures we will drag, so from automatically from there will be latitude and longitude generated into the view. So from measures we'll drag latitude and drop it into rows 3 times. Right. So we'll click on first latitude, drag sales, and then drop it into color. So we'll click on second latitude, drag profits and drop it into size. So observe the difference how the maps are getting changed. So we'll click on third latitude, drag the order quantity and drop it into color. Okay, now we'll also use one more latitude here. Click on the fourth latitude and drag the customer ID and drop it into size. So this is the fourth latitude. And change the aggregation to count distinct. So we will first extract this, because we can perform count distinct only on an extract, not on a live connection. We have discussed that earlier. Okay, so we'll perform count distinct. Right. In the row shelf, right click on the fourth latitude and select dual axis. Okay, so the row shelf, right click on the second latitude and select dual axis. Okay, so this is the view which is of a nested dual axis. So if you place one dual axis inside the other, it is known as a nested dual axis. So this is how you can create a nested dual axis. Okay, this is about the nested dual axis. So we have seen how we can make dual axis maps till now. We've seen how we can make dual axis maps. So in maps, I mean, we'll see some uh, test cases. So we'll see few of the test cases in maps. So the first test case is we will check the fields with different names but having geographical values. Example, um, ABCD. So data is of ABCD. Okay, so say it's of some city data. Okay, so the output should be Tableau should identify the field as textual fields. So the solution is to set geographical role manually. You have to set the geographical role manually. Okay. So for example, if we have So if this is the data, so Tableau identifying the field as textual fields is the output. So we have to the uh, task is to check the fields with different names, but having geographical values. Okay, say so we'll connect to the data. So basically we want to check the fields with different names but having geographical values. So the output is that Tableau should identify the fields as textual fields. These are all the textual fields A, B, C, and D. So um, to identify to make Tableau to identify these fields as geographical fields, the solution is to set the geographical role manually. So here we should set the geographical role manually. So what is A here? So it's a country data. So we'll assign the geographical role manually like this as country. What is B here? It's a state data. So we'll assign a geographical role manually of a state data. So what is C here? City data. Okay, so again we'll assign the geographical role manually as a city here. So what is D here? It's a pin code data. So we'll assign the geographical role as zip code or a postcode manually like this. Okay, like this we have assigned the geographic data geographical role manually for uh, different fields which are identified as textual fields automatically by Tableau, and but we don't want those to be as a textual fields, we want them to be as a geographical fields. So we have set the geographical role manually in Tableau like this. So this is one test case. So we'll perform a second test case where we'll be checking the fields with geographical names but having different values. Okay, um, so here um, the data would be like this. So the output is Tableau is identifying the field as geographical field, but we cannot plot the map as it is a unknown value. Okay, so you're not able to plot the map for this because there is an unknown value like A, B, C, and D. Because we are not able to uh, plot the value. So the solution is to plot these in the form of a map. Use the alias names manually. So you have to use the alias names manually. So we have the geographical data identified by Tableau, but we are not able to plot any plot any mm, plot any map on the view, because the problem is we cannot plot the map as there are unknown values here like this. So the unknown values are the data values. So um, these are all the A is not a country, B is not a state, C is not a city, D is not a postal code. So that's why we are not able to plot a graph on the view. So to plot these in the form of a map, use the areas name manually. Okay. So instead of C, we'll use China. Sorry, instead of city, you have to use not a country name but a city name. So we will use Hyderabad here for city. So if there are any unidentified locations, so we have to click on the unknown icon here on the bottom right, and we have to edit locations. So the geographically set to United States. That's why Hyderabad is not identified. Okay, so we have to change that. Okay, so you can change by selecting any city in US. Okay, so by doing though, so we are able to get the data like this. So in country, we'll change the alias name to US. We are able to plot a map now. Okay. Similarly, you can change the state and postcode also by right clicking on the aliases, and you will be able to plot a map, or because we are giving a valid data inside the dimensions or a field. Okay. So even in state we can view any state which is recognizable in the data, and we'll be able to plot a graph like this. Okay, plot a map like this. So the solution here is to plot these in the form of a map using the alias names manually. Okay. So we'll use a third, we'll go to the third test case. So in this test case, we'll be checking the fields with geographical names, but having geographical values at different levels. Okay, geographical values at different levels. So, for example, uh, so for country, state, and city. So if this is data, and our data is for country, we are showing as California. Uh, for state, we are showing a city data, and for city, we are showing country data like this. So basically, we'll be checking the fields with geographical names, but having different values at different levels. So if you use this data, so the output would be Tableau will be identifying the fields as geographical fields, but we cannot plot them in map. Okay. So I'm connecting to the data, test case 3 data. So Tableau will be able to identify the fields, country, state, and city. However, if you click on the data, it is not able to identify the data and then plot on the map like this. So this is the output. So what is the solution? So to plot them in the form of a map, we have to set the geographic roles manually again. Okay, to set the geographical roles manually, right click on the field and then go to geographical role. Then you have to set the required role. So what is the data in it? What is the data in country here? So here the data in the country is California. So California is not a country data, it's a state data. So we have to change that geographical role to state. Okay, so if you change that data to state, so we are able to plot a map like this. Similarly, for state, so what is the data point? Because New York is a state and also a city, so we'll be using a different name. So we're not able to identify the city because the state data has a city value in it. So basically we will change that role to city. So there should be a space between San Francisco. So by doing so, so we are able to plot a graph. Similarly, we can do that for city as well. So it should be of a country. You're able to plot a map now. Okay, so this is a third test case. So we have checked the fields with geographical names having different geographical values at different levels. So the output was Tableau was identifying the fields as geographical fields, but you are not able to plot them in a map. What is the solution? To plot them in a form of a map, we have set the geographical roles as manual here. Okay, right. So we'll perform a fourth test case. We'll be checking the fields which with mismatched names having same geographical values. So we'll just change the names slightly. So here, so for country, the name has some mismatch like this. So but the data is correct. Okay, so this is the data. Imagine this is the data. So I'm connecting to the data. So here, uh, the objective is to check the fields with mismatched names. So for country, there is a mismatch of the name of the field. For city and state also, there is a slight variation in the uh, name or a spelling. Okay, so we are checking the fields with with mismatch in names having same geographic values. So for country, the values are okay. So for country, it's the values are US. So for city, it is San Francisco, and the state, that California. Data is okay, but there's a mismatch in names. So the output is that Tableau is identifying the fields as text fields. The fields as text fields. What is the solution? We have to set the geographical role manually for them. So if this is the case, we should set this to country, city as city, state to state. So now we'll be able to plot a graph like this. Okay. Again, yeah, there's a spelling mistake. So if there's a spelling mistake, so we can identify with the matching location like this. Okay. So So we can identify and plot a graph like this. So these are the different test cases that we have seen to identify different anomalies and how to address those issues. Okay, so we have to note that Tableau identifies the geographic fields completely based on field names. So what are the outcomes? What are the things we need to remember or note here? So Tableau identifies the geographic fields completely based on the field names, completely based on the field names. Okay, so here if the field names were correct, Tableau was automatically able to identify that field. So Tableau identifies the geographic fields completely based on the field names. So if the field is having different geographic values, and if you want to plot them in the form of a map, we have to right click on the field and go to aliases and set the required aliases. Okay, so the field is having different geographical values. What we have done, we have to plot the values in the form of a map. We have right click on the field, have gone to aliases and set the required aliases for the field names if the fields is having different geographical values. Okay, so in Tableau, while performing the evaluations, it will make use of alias names. So how does the Tableau perform mapping at the backend? So in Tableau, while performing the evaluations, it will make use of the aliases names. Okay, so the most frequently occurred issue with map is the unknown values. Okay, with the unknown values, whenever you have a mismatched value, we will be seeing a unknown values. To handle unknown values, right click on the unknown indicator. So you are able to you were able to see a unknown indicator at the bottom right, like here. So right click on the unknown indicator in the view and select edit locations and set the required locations. Okay, so in the last example, so I've given a wrong name. Okay, wrong spelling. So to identify that, so I've clicked on the map indicator and select the edit locations and set the required location like this. So you can handle mapping issues, data issues in maps like this. Okay, so this is about different test cases that I wanted to discuss. So moving on, so there are also background maps. Okay, so there are background maps in uh, Tableau. So in Tableau we are having three types of background maps. Okay, we're having three types of background maps. So one is offline map, second one is online maps, the third one is map services. So these are the three types of background maps. Okay, so three types of background maps available in Tableau. So what is offline, what is online, and what are map services? We'll look into that. So in offline, so Tableau gets the background maps from the local machine. It doesn't require any internet connection. Okay, in offline maps, Tableau gets the background maps from the local machine. So whenever you are using any map like this, so this background map, so if it is a offline mode, so go to maps and check the background maps. So if it is offline, so if it is offline, so if you are using offline maps, so then it will be uh, taking you making use of the background maps from the local machine. It doesn't require any internet connection. So in this case, the offline maps will be located in the local machine location. So where will be they located? In C program files, uh, Tableau, the Tableau version that you are using, and go to local and maps. So here you'll be having all the offline background maps. So if you choose offline background maps, Tableau will pick up the offline background maps from this area. So you don't have any relevant uh, offline maps in the local location. That's why you are not able to see any uh, maps here. So if you want, you can download any offline maps in that location. You'll be able to see maps here. Okay, right. So that is about offline. So there's also online. Okay, right. So what is online? So in online, Tableau gets the background map from the remote Tableau servers. Okay, so you have to be online, so you have to be connected to the internet to get these online maps. So in online, Tableau gets the background maps from the remote Tableau servers, okay, so it requires internet connectivity for accessing the data, remote Tableau servers. Okay, so from Tableau 8.2 in online mode, so we are having two servers, Tableau and Tableau Classic. So, however, from Tableau 9 version, Tableau software has integrated all the features of Tableau and Tableau Classic into a single server called Tableau. So, okay, from Tableau 9, only Tableau online option is available. So that means if you select this Tableau, so that means you are using Tableau online remote Tableau servers, Okay, so Tableau and Tableau Classic have been combined into Tableau from Tableau 9.0 version. Okay, so this is the online background map option. Okay, this is the online background map option. So if you select this Tableau, so you will be able to connect to the remote Tableau servers located online. Okay, you are getting the background maps from there. So the third option is map services. Okay, offline, online, and map services. Okay, so using map services, we can add the third party background maps. So we can also add the third party background maps using map services. So within this map services, we have two types of background maps. So one is WMS server, the second is Mapbox. Mapbox. So within map services, we have two types of background maps available in Tableau. One is WMS server, the other one is Mapbox. Okay, so we'll look into what a WMS server is. So WMS stands for Web Map Service Server. Web Map Service Server. Okay, so WMS server is nothing but Web Map Service Server. Okay, so using this option, we can connect to third-party servers. So if you want to connect to third-party servers, so you can use this WMS server. Okay. So so basically map services, using map services, we can add the third-party background maps. Okay. Okay. We can add the third-party background maps using map services. So we have to note in WMS server, we have to note that to change the background map option, we have to click on map and select the background maps and check either offline, online is nothing but Tableau here, or Neo WMS. So we'll see how we can see get this Neo WMS server. So I'll open a fresh worksheet. So I've connected to the data and selected the orders table. So here I'm having only offline and online options. Offline and online options. Here I don't have WMS server option. Okay. So we'll perform a task to add a WMS server. Okay, we'll perform a task to add a WMS server. So um, we have to get the Neo WMS option uh, apart from online and offline options here. So we have to get a Neo option. So here, the earlier example, we're able to see a other option also like this. Okay, which is Neo WMS, NASA Earth observations, which is Neo WMS. So we'll see how we can add that option as well. Right. So NASA Earth observation or Neo WMS is a free mode WMS server available online. Okay. So you can browse that in Google. So go to Google and then enter Neo WMS. So this will open a link like this. Copy this link and then click on map and select background maps. Go to map services, click on add, select WMS servers and paste that link. Click on OK. Close it. So now you will be able to use the background as Neo WMS. So this is the Tableau online option, and if you use the uh, NASA Earth observation server, so you'll be getting a view like this. Okay, you'll be getting a view like this. Similarly, you can take for different cities as well or states. Okay. So this is how you can add the NASA Earth observation server to the map background, and you can even select or change the so change the option by going to the map background maps and then selecting the appropriate server. Right. So we have to note that the to the maps, we can add three types of map layers. So one is background style, one other one is map layer, and the third one is data layer. So to add different layer for WMS, click on map and select map layers. Okay, and select any one map layer. So we can select any map layers. Okay, first we'll see different map layers. So this is the topography and bathymetry map layer. Earlier we were seeing what? So we were seeing active files map layer for last 1 month on a global level. So this is a satellite information. Okay, so like that we can use different map layers also. Okay, so you can see for the last 1 month average land surface temperature also. Okay, this is a direct latest information coming from NASA. So we'll see net radiation also on a global level. Okay, so this is the ozone, and this is the population density. So like this, you can use any map layers. Okay, so so there are three types of map layers. One is background style, map layers, and data layer. So we can choose different options to show the layers in the view. Okay, like this, right? We can add different layers for WMS. So we have to select any map layer and then click on the map layers like this, right? So we'll move on to the next task. So we will create a .tms file. Now we will create a .tms file. So what does TMS stand for? TMS stands for Tableau Map Source File. TMS stands for Tableau Map Source File. Okay, so um, we'll perform this task after a quick break. So we'll come back after a quick break of couple of minutes, and then we'll look into this creating a .tms file as well. Okay, so see you in just 2 minutes. Hi. So so we're talking about the TMS files. So TMS stands for Tableau Map Source File. Okay, so um, WMS server connections can be exported in the form of a TMS file. so which gets stored into the map source folder in the Tableau repository. So documents in Tableau repository, map sources folder, so it gets stored into this location. If you um, if you export the WMS server connections in the form of a TMS file. So for that, you go to map and then background maps, WMS server, click on import. Sorry, first we have to export this. So we have to go to, you have to click on map, select background maps, and then select WMS server. In WMS server window, we have to um, click on export and click on save as. Okay. So we have to first select that option and then click on export. And you are able to see .tms extension like this. So we have to click on this and then select save as. So by default, you are getting the location map sources in Tableau repository in my documents folder. It is stored locally in my Tableau repository and map sources like this. Click on save. Click on yes. So he like this. So you go to that location again. So you'll be able to see the TMS folder like this. Okay. Tableau map source file. So TMS stands for Tableau map source file. So you have to note that if we generate a TMS file, that file can be used across multiple workbooks, which means the TMS files are reusable files. So you can use this TMS file across different workbooks. So to reuse this file, open a new workbook. Click on map, backgrounds, so in import, click on import and WMS select the WMS file. So build any map and to use WMS background map, click on map again, background maps, and you will be able to see the Neo WMS option here. So and to use it as default, click on set as default. Click on set as default for it. Okay, you have to note here that TMS files will be stored in the XML format. So all these TMS files will be stored in the form of a XML format. Okay, so you will be able to open these TMS files directly in 10 point from 10.3. You'll be able to open this TMS file directly. Okay, right. So the next option that we'll be looking into is Mapbox. So this is about WMS server. So we'll look into Mapbox now. So we'll perform a task to integrate Mapbox with Tableau. So first we'll be doing Mapbox integration with Tableau. So note that Mapbox is the third-party background maps provider, which is available in the free mode as well as as a license mode. So Mapbox is the third-party background maps provider, so which is available as both as a free mode and also a license mode, both free mode and also license mode. Right. So first, what we'll do is we'll perform a task to integrate this map into Mapbox into Tableau. So we'll go to browser and enter this URL www.mapbox.com. So click on sign in, and then first you need to sign up. Right. So we need to sign in first, and in the home page of the Mapbox, click on My Access Tokens. Go to My Access Tokens and copy the token by clicking on the copy button. First, we need to create a token. So we need to create a token. Here, so this is the token that we have. So we need to copy the token. So we need to click on this icon to copy the token. Okay. So this is the access token. We have to copy the token by clicking on the copy button here. So click on the map tab, go to map, click on the map tab, in Tableau, in background maps, select map service, select map services, then click on add and select Mapbox maps. So in the Mapbox window, click on classic, click on classic, and then paste the access token, paste the access token, and enter the style name as Mapbox. Click on OK. Okay. So create a new worksheet with the country map. Now create a new worksheet with country map. The background map, select the background map as Mapbox. Okay. To change the background maps styles, edit the Mapbox in the Mapbox services window. And select the Mapbox style as required. Okay. So you can select the Mapbox style as well. Okay. And then you can use different options. So you can use satellite also to get the a satellite view like this. Okay. So you can use different options and then look how it looks on the view like this. You have to note here that Mapbox is a new feature from Tableau version 9.2. Okay, so the new map options in version 9 are the new map options are map search, so map search, map selection, also map layers in the map box. So these are the different options, okay. To hide the map options, click on the map tab and then select map options, then and then select the required options in the map options. So to hide or show different options, you can either show or you can hide them. Okay, so these are the different map options: to zoom in, zoom out, to fix the map, and also to use a location indicator like this, or to show an area like this. So you can play around with the different map options available on the view. Okay, you can zoom in and zoom out. Okay, and you can place any data on top of this background map image also. Okay, right. So to hide any map options, you can either check them or uncheck them on the map options as shown. Okay, so there are two map options available from Tableau version 10 also. So from Tableau version 10, there are two new map options. One is custom territories, another one is finding the radius on the map. So finding the radius on the map, and also to the other one is custom territories. So if you go to custom territories, from Tableau version 10, it is possible to create the required territories on the map using custom territories options. Okay, it is newly added from Tableau version 10. So now we'll perform a task to create a custom territories at continent level using country map. Okay, so we'll click on the country geographical field and drag sales into labels. And then continent into color. And change the map type to field map. So continent into color. And sales into label. Right. So right click on the continent in the dimension in the geographic role. Select create. So in the geographical role, select create from country. Select create from country. So remove the country from the detail of the marks card. So in the color window, select any continent. It is going to highlight that continent on the map. Sorry. So we should also, so we should be actually using this continent in geographical role, create from country. So if you select any continent in the color window, so it is going to highlight that content on the map. So it is going to highlight that content on the map like this. Okay. So we have to note that if you create custom territory in any field, then Tableau automatically converts that field to geographic type. Okay, so if you create any custom territory, so the next task is to create a custom territories at the region level on the state map and display their total sales. So for this, so we'll click on the state geographical field. Drag sales into label, and then region into color. So we'll be using Tableau. We're using map options actually, map box. Right. So we'll right click on the region in the dimensions. In geographical role, so we'll select create from straight. So we'll remove state from the detail of the marks card. So in marks card, we'll select field map. So basically we have created a custom territory like this. So in this task, we have created a custom territory at the region level on the state map and display their total sales. If you select different regions, so they'll be showing or highlighting on the map like this. So this is creating custom territories. This is creating custom territories. This is a central region. This is east. This is south, and this is west. Okay. So we can create a custom territories like this. So the next one is finding radius on the map. So this is also a new option from Tableau 10. From Tableau 10, it is possible to find out distance from the top of the map with the help of the radial selection. Okay, so to get the distance or radius, we need to zoom in the map to the maximum. Okay, so that now we will find out a radius on the map. So using a next task. So we'll click on postal code. So we'll click on the postal code uh, field, and we'll zoom in. We'll zoom in the map to the maximum and using so this is postal code 66801. So we'll zoom in the map to the maximum. and using pan button, so this is a pan button, so this is a pan button, so we should drag the values to the center. So you should use this pan button to drag the values to the center. So in the map selection, you have to select the radial selection. So in map selection now, so after zooming into the maximum level and using the pan button to value to drag the values to the center. So what you do is in map selection, select the radial selection. Select the radial selection and drag it on the map. It will automatically display the radius. So it will automatically display the radius like this. So after zoom in to get back the original map, so we have to click on the reset button. So if you want the radius, you have to click on the radius like this. Okay. So this is the option for getting the radius. So after zooming in to get back to the original map, so we have to click on the reset button. So this is the reset button. So you can get back to the original size. Okay. Right. So this is about different types of maps and these different options that are available in mapping. So we can also do geocoding addresses with data blending as well. Okay. So before that, we'll see what a custom geocoding is all about. Okay. So when Tableau's basic geocoding does not contain the level of detail or roles needed, so importing custom geocoding can be a way to expand your abilities to do the geographical analysis. So when in Tableau's basic geocoding does not contain the level of details or other roles needed, so you can import the custom geocoding. Um, Using this, you can expand your ability to do the geographical analysis. So Tableau can replicate its geocoding capabilities with user-defined definitions. Okay, so you can leverage these capabilities to tailor any mapping analysis to fit your business needs. Okay, so when you decide to use custom geocoding, so you are actively deciding to expand an existing geographical role or add a new geographical role onto the view. Okay, so this is different from connecting to a data source. So you are just adding a new geographical role into the view. So you are in fact importing it into the client tools data repository. Okay, basically you will be importing the data into the client tools data repository. So this does not necessarily expand your workbook size or behaves like a it behaves like a like a built-in geocoding. Okay, so when you want the required level of detail, so you will be using this custom geocoding. Okay, so unlike the geocoding done automatically, custom geocodings are stored under my documents, my Tableau repository, local data import, as opposed to program files, Tableau local data. So here, so all those local data imports will be saved when you are using custom geocoding. So for this reason, the import is unique to each client. Okay, so you can also do custom geocoding by data blending. So when coordinates are not listed in a single data source, data blending can be used to relate two sources based off a common field. So um, you can do this custom geocoding by data blending. Okay, so to do this, when for example when coordinates are not listed in a single data source, so you have that coordinates in a different data source, so data blending can be performed to relate two data sources based on a common field in these two data sources. So geocoding can be kept in a separate file and blended in order to represent data spatially without having to import into the Tableau desktop repository as well. So this is an option to do that also. So while performing a task or an activity to do geocoding addresses with data blending. Okay, so you have seen how we can modify locations. You've also seen how to do dual axis maps. So we'll now see um, custom geocoding. So geocode, the activity is to do geocoding addresses with data blending. Okay, so objective is to convert a list of addresses into a map. A third party has also already been used to obtain the latitude and longitude of each location. So we have done using Mapbox and so. So we have used some third party tools. And now that information needs to be used in Tableau, so we have to create a map view. So websites for events also needs to be included in the view. Okay, website information is there in one file. Okay, so we'll see the uh, data, background data first. So in this file we have restaurant name, latitude and longitude data. Okay, so uh, websites for events also included in the view, so which are located in a separate source file. So we'll see how we can blend one data into another data. So okay, so we'll continue with the same workbook and insert a new worksheet like this. So we'll create a new connection um, and we'll create a new connection to the Excel using an Excel file called locations.xls. Okay, we'll connect to the view. So this is location.xls, and we'll also look into another file called events. So this is another data source. Yeah. So this is the events data file. So this is having date, restaurant name, neighborhood, address, and also the website of the restaurant. Okay. So we want this website data and also this latitude and longitude data to be represented in the view. And the common field between these two data sources is restaurant name. So restaurant name is common field. So using data blending, we'll see how we'll be using geocoding addresses. Okay, using data blending. So we'll also connect the second data source to the connection. Select Excel and select events. So events and also uh, locations are the two data sources that we are using. These two sources share the uh, common field called restaurant name. Okay, restaurant name is the common field. Okay, restaurant name here and restaurant name in other data source. Okay, so this is a common field. So we'll create a map view by bringing longitude to columns. And then latitude to rows. Okay. And label as restaurant name. So we'll add in events information by sizing the marks by the number of events. Okay, so we'll go to the event log. Um, so we'll size the marks by number of events. So we'll use number of records into size and include the website in the detail. So this will help us to get the website name in the tooltip like this. So if you hover over the restaurant, you will be able to see the website. Okay, so these are the different restaurants in this geographical region in this pin code, zip code location. Okay, and we can update the tooltip as well. So even you can choose to go to worksheet and then go to tooltip and delete this latitude and longitude. Okay. So in the view we can format here. Okay, in the tooltip will increase the size of the restaurant name and remove the we have removed longitude and latitude values, and the will change the number of records to number of events. We'll preview this, so it will look like this. Okay, right. So you are getting the correct tooltip by highlighting the restaurant name, website, and also the number of events. Okay, so we can do the geocoding by using data blending like this. Okay, so this is about geocoding data using data blending. So what have you done? We have used restaurant name as a common field. There is a link established on restaurant name when we are using data blending technique. So from one data source called location mapping, we have used latitude and longitude, and from events log we have used website name and number of records, and we have plotted that on a single view like this. Okay, right. So you can do data blending using geocoding like this also. So the next topic is uh, path mapping of point to point distribution, and also um, we will see um, using background images for spatial analysis. Okay, so we'll see these examples in the tomorrow's class, where we'll be discussing background images. Okay, so and also point to point mapping. Okay, so you can see we'll see how we can do this point to point mapping, and also see how we can use these background images to plot our data. So this is a medical information, so we'll be using the background images like these to plot the data. Okay, so we'll see those topics in the tomorrow's class. Okay. See you tomorrow. Any
Perfect.
questions till now?
No, I'm good, Kranti.
Okay. See you. Bye.